The RealAgriculture.com Beef School is presented by DuPont Pioneer. To find more Beef School episodes, go to beefschool.ca. Sean Haney here with RealAgriculture.com. I'm here for another episode of the Beef School, and right now I'm joined by Dr. Tim McAllister. How are you doing today, Tim?
Very good, thank you.
Okay, Tim, we're going to talk about inoculants. Inoculants with silage, and the whys, the why nots, and talk about some of the different types and cover the whole gamut. So,
Sure.
What are inoculants in terms of silage?
Well, inoculants are basically bacteria that have been selected for the ability to enhance the fermentation process during ensiling. And there's a number of steps that are taken to select inoculants that have the properties that'll enhance the ensiling process.
Okay, and what value, like, they enhance it, but what does that mean?
Well, the biggest thing they do, there's a number of generations of inoculants that have been developed over the years, and they've got different goals depending upon as they become more and more advanced. So the first generation inoculants, really what they were targeting at was accelerating the decline in pH that takes place right after the forage is put into the bunker or into the pit. And so the more rapid that pH decline takes place, then the faster is the aerobic respiration that takes place is by the plant cells themselves or by spoilage organisms that becomes impeded or inhibited faster, which then conserves the forage that's in the pit as a whole. The second generation inoculants, what they focused on is not only that rapid decline in pH, so they had the bacteria in the mixture that did that, but they also focused on improving the stability of the silage once the silo was opened up. And so as soon as you open up the silo, you're re-exposing that material to oxygen. And those spoilage organisms, although a lot of them are killed during the ensiling process, not all of them are. They go into a dormant state, and once that oxygen becomes available, they can become active again and then start to cause deterioration of the silage as well. And so that second generation inoculant, what it does is it produces a acid called acetic acid in fairly low concentrations, but it acts as an inhibitor against those spoilage organisms and conserves the forage then as soon as the pit is opened up as well. The third generation inoculants, what they focused on is actually all of those other two items that I've just discussed. But the third thing is that they produce an enzyme that helps improve the digestibility of the forage as well. That enzyme is called ferulic acid esterase, and what it does is it breaks down the linkages in the plant cell wall to make them more digestible once the animal consumes the feed itself. So that's the third generation, and that's the latest inoculants that are available on the market today. We're currently working on what we call a fourth generation inoculant, and it's still at the testing stage. And the fourth generation inoculant does all of the three that I just described, plus it has a probiotic effect in terms of you're administering a microbe that has beneficial effects on the health and digestion in the animal itself. And so that's the fourth generations. Those are not commercially available. They're still at an experimental stage and under development.
Sort of the same benefit like a yogurt, a probiotic yogurt?
Very much. So, and you can buy probiotics now that you can add to the diets of the cattle. This is the idea here, is the producer would essentially produce their own probiotic in the silage pit when they're siling the forage itself.
So essentially, no matter which generation you're using, I guess, there's benefits for the cattle and for the producer.
That's correct, on both sides. And the biggest one, that first one that we talk about is that reduction in dry matter loss. So as long as there's activity going on in the silage, when you first put the forage in, that's why it's so important to cover the silage as quickly as possible, to pack it as thoroughly as possible. All of that is involved in excluding oxygen from the system. And as long as there's aerobic respiration going on, then you're losing dry matter from the silage. And inoculants can help lower that dry matter loss.
Lots of benefits. It's a good story. Why is it not 100% usage?
Well, I think because there's a different situations. One of the things I really look at it as an insurance policy in some cases, because you can ensile forages as well, particularly cereal silages, without an inoculant, because there's natural bacteria that are growing on the forage itself that will participate in the fermentation process and the ensiling process to end up with silage at the end of the day. The problem is that population is unpredictable. You never know whether it's going to to be there in adequate numbers or the adequate types. And when you're talking about the precision type of manipulation that I described with the first, second, and third generation, you're not controlling that like you are with an inoculant. So that's really the advantages of an inoculant, is it makes the process much more predictable. And siling itself is a pretty complicated process. The microbiology of that is incredibly complex as well. We're just using sophisticated techniques now, using molecular biology in that, to document what we call the microbiome of silage. You have a microbiome, you've probably heard about the microbiome that each of us harbor as people. Well, silage also has a microbiome as well. And so characterizing that microbiome, and what we know is that that microbiome can differ on the same forage from year to year with different growing conditions, different environmental conditions. All of that can affect that microbiome. And really the problem is that when you make that silage, that microbiome is unpredictable, as adding an inoculant improves the predictability of the microbes that are there to ferment the silage.
So that really is the opportunity cost there, that if you not using it, the potential for less stability in the pit.
That's right.
Yeah.
Definitely. And like those are pretty proven. It depends on which inoculant you're using. Like not all inoculants are the same, because not all bacteria in those inoculants are the same. But one particular inoculant that we use, like with Lactobacillus buchneri, is the organism that infers that stability by producing that small amount of acetic acid that I talked about. That's pretty consistent in terms of that response and improving aerobic stability. And you won't have that with just a straight harvest without an inoculant.
Yeah. More common in barley or corn, or is it more effective?
They work well in both of those cereal silages. Probably, if you look at the U.S., probably corn silage gets a bit more than what we do on barley silage up here. But I think the market's growing, and people are realizing the value, and it's being used more as time goes on.
Okay, Tim, thanks a lot.
Thanks a lot.
We'll talk to you again soon.
Okay, thanks a lot.